All right, so here, Pascal's triangle and the binomial theorem, we want to know how can I rewrite x plus y to the power of 6. So we have this table when we want to fill it in for combinations. Remember, a combination is what we talked about last week, where the order doesn't matter and objects can't repeat. So here on this table, on the left, it's n is the total number, and the top is r is the number of choices. So I'm going to share, I printed this for us to fill out. Okay, so this is like 0, choose 0. This box right here is going to be 8, choose 0. So you have a button, I didn't have my calculator last week, but if you have a graphing calculator, if you hit the math button and go over to probability, you have this down at number 3. It's focusing. So I could do 8 and then hit over, choose 0, and I get 1 for this bottom box. So this box right here is 0. This box right here, sorry, is 0, choose 1. This box doesn't exist. If we have 0 things, we can't choose 1. Same thing if we have 0 things, we can't choose 2, 3, 4, 5, 6, 7, or 8 of them. So none of these boxes are going to have anything in them. If I have 1 thing, I can't choose 2 because we're not allowed to repeat. If I have 1 thing, I can't choose 3. I can't choose 4, 5, 6, 7, or 8. If I have 2 things, I can choose 2 of them, and there's only 1 way to do that. If I have 2 things, I can't choose 3, or 4, or 5, or 6, or 7, or 8. If I have 3 things, I can choose 0. There's 1 way to pick nothing. I can pick 1 thing. There's 3 choices. I can pick 2 things. There's 3 ways to do that. Or if I have 3 things, I could pick 3 things. And there's also only going to be 1 way to do that, to pick all 3. But you can't pick 4, 5, 6, 7, or 8. And so same thing all the way down. If I have 6, hold on, did I mess up here? So it should look kind of like that. Those are the things that those aren't even possible. They shouldn't make sense for what this is. So by the way, this is problem 10-151. So if I have 4 things, I choose 0 of them. There's only 1 way to do that. 5 things to choose 0, only 1 way, and 1 way. Likewise, if I have 8 things and I want to choose 8, there's only 1 way to do that. And I can also do that on the calculator. 8, choose 8, and I get 1. So this first column all the way down is 1. And then this last like diagonal here is going to be 1. If I have 7 things and I choose 7, there's only 1 way to do that because order doesn't matter. So we have to fill in the rest of this. So this box right here is going to be 4, choose 1. So 4, choose 1. And there's 4 ways to do that. Likewise, this whole second column going down here with the number 1 at the top, you can see it's growing by 1. If I have 8 things and I want to choose 1, well, there's 8 ways to do that. All right, so now we have to kind of do the rest of them. 4, choose 3. Is 4. This box right here is 5, choose 2. So 5 choose 2 is 10. Then I want to do 5 choose 3. So remember that has 5 objects and I'm picking 3 of them. Order doesn't matter and I can't repeat. I also get 10. Then I want 5 choose 4, which is 5. Down here I want 6 choose 2 is 15. I recommend figuring out how to do this on your calculator. If you have the TI-30, the small, not graphing, but the scientific calculator, there is a way to do that on there too. Let me see if I can find an image of it. So if you have the TI-30, it looks like this. You're going to hit this button right here that says PRB for probability. And I believe when you hit that, you can scroll over to one of them that says like NCR. And you type I think you type your first number in, then you hit that button for probability, then you type your second number. I recommend trying it because, like I said, if this comes up on your test on Thursday, you're going to want to know how to do it, or find it on. There are online calculators that will do it too. All right, so let's share this. This is what I wanted to share. All right. It's not 21, sorry. It should be 35 again. And then 8, 28, 56, 70, 56, 28, and 8. So get that copied down. Okay, so on problem 52, it shows you a picture of a triangle, kind of like this one. Ours is kind of written with those hexagons. In the book, it doesn't show it with a hexagon there, but it just shows that kind of breakdown. So what we're going to do, this is called Pascal's triangle. So we're going to copy these numbers from this table up here into Pascal's triangle. So you can see it was 1, 1, 1, like we have here, 1, 2, 1, 1, 3, 3, 1 for this next row. And so go ahead and copy all of those down into here. Okay, so you will be able to create this triangle without this table and without your calculator. So we want to kind of figure out what the pattern is. How can I get this next row from the row above it? We can fill in the next row because we have it in our table. And the book actually wants us to go all the way to row number 10, I do believe. And you write the numbers like in between the 1 and the 8 would be a 9 here. So this is what we call row 0. This is row 1. This is row 2. So just like up here, when we started with 0, that's the row number it is. So row 0, row 1, row 2. So this one down here is row 9 that I just started and only got the 1 and the 9. We want to figure out how to fill these numbers in. So the pattern to fill this in is you add the 2 above it. So like right here, this 3, when that focuses. So this 3 is from 1 plus 2. This 6 right here is 3 plus 3. This 15 is 10 plus 5. So you're always adding the 2 numbers above it. So like right here, this 9 comes from 1 plus 8. This row, this number after the 9, we're going to add 8 and 28. So this would be 36. Here we're going to do 28 plus 56. So this one will be 84. Again, we're adding each of these. And then it's always ones on the outside. So 56 plus 70, we get 126. 126 again. That's why they start repeating. 84, 36, and 9. So see if you can fill in row 10. All right, so row 10 should be 1, 10, 45, 120, oops, 210. I wrote that 120 in the wrong spot. I've got all of these kind of off a little bit. Okay, sorry. 110, 45, 120, 210, 252, 210, 120, 45, and 10. So again, if you didn't have your calculator and you didn't remember how to get these numbers, you can make this triangle. It doesn't take that long to just add the numbers up. So you're adding the 2 above it. And remember where these numbers come from, was the choice. This one right here would be like 10, choose 1. This first outside part of the triangle is always, whatever the row it is, choose 0. How many ways can you choose 0 things? How many ways can you choose 1? How many ways can you choose 2? And so on. So keep this handy for when we move on to problem 53. Jack, 1 second. Okay, so on 10-153, so it's gonna look like we're shifting gears, but this is gonna build off what we were doing. Our goal is to be able to rewrite a plus b to the power of n. So we're gonna start with a plus b squared, which we know is a plus b times a plus b. So I can make a box for that. And I get a squared plus 2ab plus b squared. So how many terms are there in this? So there are 3 terms. And it wants to know what are the coefficients. Are 1, 2, and 1. Okay, sorry. And then B wants us to do a plus b to the third, which we know is, I don't need to write it out, but I already started it. A plus b times a plus b times a plus b. So basically we're going to take what we got from part A and multiply it by another a plus b. So this was a plus b squared, the first two, and then another a plus b. We get a cubed 2a squared b. This is a squared b. This is 2ab squared, ab squared, and b cubed. So this is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Which we can see there are 4 terms. And the coefficients, remember coefficients are the numbers in front. So we have 1a cubed, 3a squared b, 3ab squared, and 1b cubed. So 1, 3, 3, 1. And we're going to do one more. We're going to do a plus b to the 4th. So our goal at the end of this is to be able to do these somewhat quickly without having to make boxes. Yes, you can always make a box, but if I'm going to ask you to do a plus b to the 7th, you're not going to want to do all these boxes. You're going to want a shortcut, which is kind of where we're headed here. So this is a cubed, 3a squared b, 3ab squared, and b cubed. So a to the 4th, a cubed b, 3a cubed b, 3a squared b squared, 3a squared b squared, 3ab cubed, ab cubed, and b to the 4th. So this ends up being a to the fourth plus 4a to the third b plus 6a squared b squared plus 4ab cubed plus b to the fourth. So there are 5 terms, and our coefficients are 1, 4, 6, 4, and 1. Yes, Forrest. No, I'm not done. Okay, so looking back up here and looking at what we just did, you can see that these coefficients come from our triangle here. So 1, 2, 1 is here. 1, 3, 3, 1, 1, 4, 6, 4, 1. So these are going to be the coefficients in term of our binomial expansion. So if we're doing a plus b to the 6th, I'm not going to make any boxes. So we already know, since this is a power of 6, we're going to have 7 terms. And again, since this is a power of 6, we want to go to row 6 on our triangle. So our coefficients here are going to be where the 6 is. 1, 6, 15, 20, 15, 6, and 1. So we go to row 6. That's the one with the 6 after the 1. Those are going to be our coefficients. So we already know it's 1 something plus 6 of something plus 15 of something plus 20 of something plus 15 of something else plus 6 of something else plus 1 of something else. So those are the numbers in front. And then this is a plus b to the 6th. Well, notice when it was a plus b to the 4th, it started with a to the 4th. So this first term is going to be 1a to the 6th. And then if we look at all of our exponents on this last problem, sorry. So like here, this is a to the 3rd, b to the 1st. We don't really write the 1. We notice these two exponents, 3 and 1, have a sum of 4. These two exponents, 2 and 2, have a sum of 4. These two exponents, 1 and 3, have a sum of 4. This is b to the 4th, which is 4. This is really like also has b to the 0, which we don't count. So here our a's, they're going to go down. This is going to be a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, or just a. And this would be a to the 0, which we don't really write. And then our b's, they're going to do the opposite. This is b to the 0. This is b to the 1st, b squared, b cubed, b to the 4th, b to the 5th, and b to the 6th. All right. Are there questions on that? So that's kind of 154. I went through kind of the patterns on 154 and 155 also. So for 156, let me open the book. Wrong one. Okay. For his homework assignment, Andrew has to expand a plus b to the 9th. He does not know the coefficient for the term. 1 second. For the term a cubed b to the 6th. He starts by writing out the first 9 rows of Pascal's triangle when his friend Robbie says just use combinations. What combination should Andrew use, and what is the coefficient of a cubed b to the 6th? So he wants a plus b to the 9th. And we're just looking at the coefficient of a plus b, or a cubed b to the 6th. 1 second. Sorry. So we wanted a cubed b to the 6th. So a few things. So we know that this a plus b to the 9th, if we were to write it out, we're not going to write it all out. We are just concerned about this term right here, and we want to know what the coefficient is in front. That's all we care about. We could write it out, but we don't want to. We know that there are going to be 10 terms. If it has an exponent of 9, it's going to have 10 terms. And then, so we know we would want to go to row 9. And so this one, this a cubed b to the 6th, if we think about where it's going to be, we know the coefficients, if we wanted to list them, are going to be 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1. We know it's going to be one of those numbers. So there's a couple of different ways to do it. If you remember where these numbers came from this top chart when we were doing this n choose r on our calculator. So all of this was 9 choose 0, 9 choose 1, 9 choose 2, 9 choose 3. So if we want a to the 3rd, we're going to want to look at 9 choose 3 or 9 choose 6, because these are both going to be, we can see that they repeat. So these are going to be the same things. And so we can type that into our calculator, or we can just say this is choose 0, choose 1, choose 2, choose 3. So it would be 84. And if you're like, that's really confusing, I don't get this choose thing, if that part doesn't make sense, don't worry about it too much. Hopefully you can get this row from your triangle. You should all be able to create this triangle from scratch. You just start with 1, 1, 1, 1, 2, 1, and then like I said, we're adding. 1 plus 2 is 3, 2 plus 1 is 3, and then a 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and a 1. So you could create that triangle and get down to the 9th row. You're also welcome to just count the terms. So we know it would start with a to the 9th, and it would go down. So this would be a to the 9th, a to the 8th, a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd. So if counting works better for you than this choosing option and plugging that in, go ahead and do that. I think it's easier to count personally, but that's me. So again, we know this one, if this is a power of 9, this first term is a to the 9th, and then our a's go down in exponents. So a to the 8th, a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd. And we also know our b's go up. B to the 0, B to the 1st, B to the 2nd, B to the 3rd, B to the 4th, B to the 5th, and B to the 6th. Okay, so on 10-157, we're going to look at a plus b to the 11th. And it asks, so how many terms are there? So if this is to the 11th power, how many terms are there going to be? What do you guys think? Type it in the chat. How many terms are there if we wrote this all out? So a few people have answered privately, and yes, you guys are all correct. Yeah, so there are going to be 12 terms here. There's always one more than the exponent. So part B then says, what is the 5th term? Well, we have a couple of options. Our triangle doesn't go down to row 11, which is what we would need here. We could add row 11. They're only concerned about the 5th term here. So if I wanted row 11, this would be the first term, 11, and we'd have 56, 165, and 330 would be where the 5th term is. So again, you could just count them, or you could use your combinations here. This would be 11, choose, and this is where it's tricky because this is choose 0, choose 1, choose 2, choose 3, choose 4. It would be 11, choose 4. You have to remember that choose 0, like I said, or you just count them. So the 5th term has a coefficient of 330. And then remember, this would be a to the 11th, a to the 10th, a to the 9th, a to the 8th, a to the 7th. In our B's, this starts at b to the 0, b to the 1st, b squared, b cubed, b to the 4th. And so 330, a to the 7th, b to the 4th. Because these two exponents have to add up to that exponent there. So for part C, they're saying, okay, well, what about x minus 2 to the 11th power? And we just want to find the 5th term. That's all we're concerned about here is the 5th term again. So what you would want to do is substitute a and b. In this problem, we had a plus b to the 11th. Flip that focus. And here we have x minus 2 to the 11th. So here our a from up top is x, and our b is -2. If we're kind of saying plugging this in here, A would be x, and B would be -2. So this would be 330. A is x to the 7th, and B is -2 to the 4th. And I just took this and this. A is x, and B right here is -2. So I plugged them in. So then we need to do -2 to the 4th. So that's the same as 330 x to the 7th times 16. -2 to the 4th we know is -2, -2, -2, -2, so it becomes positive. Make sure if you plug this into your calculator, you do your parentheses, and then 16 times 330 is 5,280 x to the 7th. So sometimes they'll just ask for one term, and sometimes they'll ask for the whole thing. So on this next one, it says use Pascal's triangle to rewrite u plus v cubed in expanded form, then answer the questions. So u plus v cubed. We know, so using Pascal's triangle, you know you're going to go to row 3 here with 1, 3, 3, 1. So this is 1 something plus 3 something plus 3 something else plus 1 of something else, just because those are the coefficients here on row 3. This first term is going to be u cubed. Our u's are going to go down, u squared, u to the first. And if you want to write this as u to the 0, so you make sure you remember that one, that's fine. And same thing with our v's. This starts as v to the 0, v to the first, v squared, and v cubed. So now just simplifying that, because we know we don't write the ones and we don't write v to the 0. This is just u cubed plus 3u squared v plus 3ub squared plus v cubed. What are you doing, buddy? Oh, thank you. So again, we got the coefficients from our triangle, and then our exponents, the first one, we start at whatever this number is and we count down, and then we start at 0 and count up for the other one. So here they want us to find 2x plus 3 cubed. And it says by substituting u for 2x and v for 3. So this is the same thing here. So this becomes 2x cubed. Everywhere we see a u is a 2x. Everywhere we see a v is going to be a 3. Plus 3 times 2x squared times 3 for v, plus 3 times 2x times 3 squared plus 3 cubed. So I just took this, and everywhere I saw a u, I plugged in 2x with parentheses, and everywhere I saw a v, I plugged in 3 with parentheses. And then we have to simplify that. We can't leave it. So 2x to the third is 2x, 2x, 2x. So this becomes 8x cubed for the first term. Yes, Forrest?
No, I play cards.
Yeah. Plus this term right here. So we have a couple things going on. We have 3 times 2x squared times 3. So 2x squared here, this part becomes 4x squared without parentheses. So this is 3 times 4x squared times 3, which becomes 36x squared because you're just multiplying all those numbers together. 3 times 2 times 2 times 3. Here, 3 times 2x is 6x times 3 times 3. No, 3, sorry. So this becomes 6x times 9, which becomes 54x, plus 3 to the third is 27. Okay, so for B, they want us to do x minus 1 to the 5th. So I'm just going to use my triangle here. We're going to go to row 5 and we're going to find our coefficients. 1, 5, 10, 10, 5, and 1. So again, you just go to that row to find your coefficients. And then we start, so this would be x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, x to the 0. Whatever this first term is, we start with this exponent and we count down. And then here we start, this would be -1 to the 0, -1 squared, not squared to the first. This is -1 squared, -1 to the third, -1 to the fourth, and -1 to the fifth. Remember, your two exponents are always going to add up to whatever this exponent is here. And so now we have to start simplifying. So -1 to the 0, anything to the 0 power we know goes away. So this becomes x to the 5th. So right here, -1 to the first is just -1. So this becomes minus 5x to the 4th. -1 squared we know is positive. So this again, negative 1 squared becomes positive 1, so this just becomes 10x cubed. Negative 1 to the third becomes negative 1, so minus 10x squared. Negative 1 to the 4. Yeah, negative 1 to the fourth becomes positive 1, so this becomes plus 5x. And then negative 1 to the fifth becomes negative 1. So it's x to the fifth minus 5x to the fourth plus 10x cubed. And so whenever it's a minus in here, you can see that the signs are going to alternate. It's positive, negative, positive, negative, positive, negative. All right, before you guys go, I did not take attendance because I was running behind at the beginning. So I need to let me just take pictures of who's all here and then I will do it later. Okay, so the idea today, if whenever you're doing one of these binomial expansion, 2 terms to some power, we can use Pascal's triangle, which is this thing here, which we can make without doing this choosing idea. And these numbers in front are going to be the coefficients, or at least at the beginning. And then we're always going to start with this first thing to this power. It counts down. And the second one is going to count up. And so remember, if this is a power of 5, there's going to be 6 terms here. If it was the power of 11, there were 12 terms. So the second page of this resource page is exactly the same thing. And it shows you the first part, kind of what these look like in expanded form. And it shows you Pascal's triangle written a few different ways. Okay, so that's all for today. You have your homework. Thursday, we have our test during class. Tomorrow, we are going to do like a short assignment and then the review assignment and team test Wednesday, test on Thursday. If you have questions, let me know. Like I said, if you're having problems uploading your assignment, go to Google Classroom and tell me that. And I will probably just wait to grade and hopefully it's all worked out by tomorrow if you are one of the people that weren't able to get them in. But otherwise, you're free to go and I will see you tomorrow.